It is a great honor to have been asked to deliver a keynote at Assets 21. This year marks the 50th anniversary of the Trace Center, and we have had opportunities to celebrate the impact on the development of accessibility over the decades. The dream that mainstream information technology could and should be accessible to everyone, regardless of disability or the assistive technology they use, has been at the core of our assets community. One of the developments over the decades has been the active involvement of end users in all stages of technology innovation. Such approaches are referred to as user-centered design, participatory design, participatory research, and participatory action research. I would argue that most of our work falls into the first two concepts, which encourage participants to engage in co-design, contributing to an iterative cycle of requirement solicitation, design, and continual evaluation. Some researchers are increasingly engaging in participatory research, in which stakeholders are actively engaged in setting the research agenda as research investigators. We see this especially within the assets community, with active researchers who have visual and hearing impairments, physical impairments, and those who identify as neurodiverse. But what about individuals with severe speech and physical impairment, and those with language and intellectual disabilities? Communication is the essence of life. The ability to communicate develops throughout our lives from birth onwards. For most of us, speech is the medium we would use. Unfortunately, for many people without intelligible speech, communication can be very difficult or even impossible. The academic field of AAC has been supporting people with varying degrees of speech impairment for over 40 years. The term AAC describes methods and strategies used to augment unintelligible natural speech or to provide alternative solutions for individuals with no speech. This can range from unaided methods in the form of gesture or sign language through to paper symbol and word boards and electronic speech generating devices. AAC can also support the understanding and development of language skills. My work in AAC began in South Africa in the mid-80s when I studied rehabilitation engineering. We had such fun reading papers from the Trade Center and attending workshops at early international conferences where we learned to make basic chin switches using empty foam canisters and simple switch technology. Speech output transformed lives for so many people throughout the world. This transformation has continued, and we now have a plethora of AAC systems which can be downloaded onto mobile devices or purchased from companies who provide invaluable training and support. Digital AAC range from simple dedicated technologies such as voice recorders, which can be used with emerging communicators. As a researcher, it is wonderful when research is translated into commercial products. One such technology is visual scenes, which was first conceived by Norman Arm at Dundee and was developed within a European research project. Pre-stored words and phrases can be accessed using symbols on dynamic pages in the form of dynamic screens, while strategies such as semantic compaction can provide users with efficient and fast ways to retrieve pre-stored words by sequencing up to 3 icons. These systems do have the limitation of placing the responsibility of remembering locations and codes, but some users do become highly proficient communicators. Recent advances in AAC intervention is focusing on the importance of providing access to literacy learning for everyone, regardless of perceived intellectual abilities, as this is the key to independent language development. Finally, most of the research within the AAC technology field has focused on how to improve the speed of typing for literate users. This remains the holy grail, as communication rates remain restrictive at 10 to 15 words per minute for keyboard users, with acceleration techniques such as word prediction. These rates decrease to 1 to 2 words per minute for switch users. Dundee is currently piloting a novel interface and prediction system which not only predicts words but whole phrases which can be selected within the typing area during interactive conversation. Watch this space. Despite the advances in digital AAC, the reality is that users seldom take control of a conversation. Instead, they respond to closed questions with short answers. Considering that the choice of vocabulary is in the gift of others, makes it difficult for pre-literate users to explore new vocabulary independently. In his Communication Matters Conference keynote in September, Martin Pistorius reflected on his emergence from being locked in and his frustration of not having access to the vocabulary he wanted. Despite the involvement of expert AAC practitioners who were unaware of his level of understanding. My research has focused on extended conversation and the fact that users of AAC seldom engage in personal storytelling. This is partly due to lack of experience. We develop skills through doing, through conversing. The ability of appropriate vocabulary and the effort and time it takes to generate utterances. Digital AAC is therefore abandoned in favor of low-tech and unaided AAC, which is quicker and far more reliable. Research suggests that one of the factors underlying the low adoption, high abandonment rate of AAC is the limited involvement of end users throughout the development cycle. Instead, proxy users, in the form of clinicians and parents, take the role of end users. If people who use AAC are involved, this is mainly as informants who comment on the final product and not as co-designers. In my experience, even clinicians are not involved in co-design and therefore are not well equipped to demand more effective systems as they are constrained by viewing AAC within the same or similar paradigms we have used since the 80s. Computing in Dundee has always put a lot of emphasis on user involvement. In 2005, our move to a new building allowed us to create a custom-built user-centered space. Initially, this was for older people to encourage peer support, research, and teaching. In 2010, a group of adults who use AAC formed the Straight Talking Group, and in 2013, the Tap and Talk Group was established to support adults with aphasia in the use of mobile technology. All three groups work with students and researchers on projects and teaching across the university. Members of the Strike Working Group have also been trained to be heuristic evaluators and work with us on commercial consultancies. Annalu established the need to include disabled and older end users in all stages of technology design in the 80s and 90s. His legacy has continued, and contrary to many who contend that people with intellectual and communication needs cannot play an active part in user-centered design, we have demonstrated that by adapting methods, we can enable meaningful involvement. It gives me great pleasure to showcase some of the projects I have been involved in over the years to demonstrate how we have adapted user-centered design methods to engage users with severe speech and physical impairment and/or intellectual impairment in our research. I mentioned earlier the notion of empowering end users to think beyond their current practice. This is, I suggest, one of the major barriers to innovation in digital AAC. I recall being told by a therapist that no one would ever reuse conversational material for personal storytelling. It was only when I realized that the clinicians were trying to match my vision onto the current AAC paradigm that I understood the need to train end users in user-centered design. End users need to articulate the problems and engineers need to bring new ideas. By understanding the environment, the context, and the required tasks, engineers and end users can work together to innovate new technology and paradigms. An important stage in co-design is being able to gather ideas from end users. We are able to do this with our user groups by visualizing problems and then engaging in discussion around this. Here you can see how ideas offered by a group of adults with communication and intellectual impairment contributed inspired ideas. This strategy of visualizing ideas with this group is already used when reviewing what clients in activity centers want to do. So we were already using what worked. Nothing was deemed impossible, and we were able to discuss what might be possible. We also used theatre to encourage users to express their ideas, and more about this can be found in Suzanne Pryor's PhD thesis. One of our projects tackled issues around enabling children to tell stories about their day at school. Instead of having staff store conversational material into a device, we wanted to demonstrate how this might be achieved using data-to-text technology. This was such a new concept, and staff and parents found it difficult to imagine. We were fortunate to have 2 students construct a simulator which demonstrated how data could be collected. We did this using RFID tags. How the data could be stored in a database and how data-to-text technology could be used to transform the data into different versions of a story. We used the simulation when we met staff and family as one way to demonstrate the technology behind the project, and this stimulated constructive discussions with all stakeholders. It was also a way to explain the project to children. As a part of the early stages in the How Was School Today project, we embedded a researcher in a special school. Rolf Black became a member of staff and would shadow the children throughout their day. This highlighted practical issues within the school day. For example, it was when the child's day veered away from the set timetable that interesting things happened. We also observed the use of voice recorders to record nuances of a story that could not be captured by sensor data, and the importance of talking about people. There is nothing new about the value of ethnography in HCI research, but it took thought and discussion to navigate initial ethical concerns. Adapting a focus group methodology took a little thinking. We wrote up all the discussion questions so that participants who used AAC could compose messages asynchronously. Facilitators would alert the moderator when participants were ready to contribute, so the discussion was not necessarily sequential. We also had a Makerton signer to support people with intellectual impairment. The role of the assistant moderator was to weave a narrative so that we could present the group with what they had said, which then stimulated further discussion. I will never forget one participant's reaction when I presented the words back to them in narrative fashion. Visibly surprised, the participant said, "You listened to us." In order to achieve our aim to support narrative, we also undertook observations in the special school. It was especially important to observe how staff supported narrative, as there was already a culture in the school to program multi-message AAC devices. Written home diaries and stories were also sent home so that the children could tell the family what had happened at school. The structure and focus of these stories help to frame the user requirements. The eventual system allows the users to evaluate story items by adding positive or negative comments when interactively narrating their story. Paper prototyping can be useful with our user group, and we were able to make use of this to demonstrate the implementation of social stories to support dental patients with intellectual impairments. Co-design often involves the users having a say on how they think an interface might look like. Instead of having participants draw ideas, we can use physical artifacts on a magnetic board, which encourages physical action and discussion. For some of our user group, prototyping needs to be digital so that our participants can engage in co-design. In this way, we get feedback on the iterative versions of a prototype, slowly developing a system that supports the users to access new opportunities for language development and interactive communication. I'm now going to show you a video of a young cerebral palsy child who was helping us to develop an interface to tell jokes. She is a switch user, so you will hear the verbal prompts as the system scans around first line, last line, first line, last line. This was one of the first times that she used the system, and we were interested in how intuitive or easy the interface was to use. So here goes.
Say again, what do you call a spicy missile?
Spicy missile?
Yes.
Spicy missile. Say again.
What do you call a
Okay.
spicy missile? I have no idea.
Say
What do you call a spicy missile?
okay. Say again. Okay.
No, it's difficult to get
Say
the okay
again.
at the right time.
Okay.
But she's fantastic.
Yeah.
First line. Last line. A hot shot.
A hot shot! Well done.
Okay.
That's very funny.
Say again.
You will have heard the use of first line, last line, first line, last line. This was changed to question, answer in the final system. However, it is also important to note how the child succeeded in controlling the delivery of the joke, which gave us confidence that the system was intuitive and could be used by operating a single switch. As with any user-centered design, we must build in continuous evaluation. I'm now going to show you a video of a child using the Harvard School Today prototype. You might recognize Anne, not her real name, from the previous video, a few years older. I'm now going to play you the video, remembering that this child uses a switch at her head. You will hear her sharing an experience from the day before with her therapist. Please note that the therapist was not in school the day before. You will also hear a pre-recorded message within the story. If you remember from our observations, we include a voice recorder in the system to capture information not available through the sensor data. The eventual system also allows users to evaluate story items by adding positive or negative comments when interactively narrating their story by skipping to the bottom area of the interface. So here goes.
Then I went to junior primary instead of meeting.
Right. Lolita. Junior primary. What a fine that was.
Yeah, visitor was there.
Oh, a visitor. Right. And what the visitor was doing.
The dental hygienist came to give a talk.
Oh. Dental hygienist.
Yeah, visitor was there.
Oh. That was a visitor. Okay. That's why you went to junior primary. What did you think of the talk?
She's nice.
She was nice.
There
That's
you
good.
go.
Very good.
The video demonstrates a number of things, and you can look at the paper to get the full analysis. In her PhD, Suzanne Pyer demonstrated that individuals with severe speech and physical impairment, with or without intellectual impairments, can engage with a range of user-centered design methods. Interestingly, the use of diaries and talk aloud pose challenges for all participants, whether they are disabled or not. And yet, despite this, research by Jess Batram found little reference to participation of users of AAC in the design of symbol-based AAC systems. When references were found, the way in which participation was reported did not demonstrate an understanding of UCD. The challenge here is for the AAC community, reviewers, and funders to demand active inclusion of end users, in addition to multidisciplinary teams in digital AAC innovation and research. Having said this, one of the challenges for industry and research is access to people who use AAC. This group is diverse and difficult to recruit, and yet I believe that we can and should regard people who use AAC as experts in their own right, working with them to value their insights and skills. The next challenge is to move towards a more participatory research model in which end users are themselves researchers. There are examples of research projects which have people who use AAC on advisory groups, and some projects have succeeded in attracting funding to employ end users on project teams in their role as expert users of AAC. If we are to aim for true participation of people who use AAC as academics on technology research projects, we will need to actively support academic study for people with complex disabilities. A real chicken and egg dilemma. My first call to arms is the need to provide expert support for daily use of assistive technology, which includes digital AAC for the most complex users. Rowan Slaughter has proposed the concept of an assistive technologist whose role is one of chief interrogator, ensuring that technology is deployed in an integrated way to maximize the benefit of technology to meet an individual's goals. Dundee has identified a lack of training in this area, and we launched a unique master's degree in January 21 to meet this need. I have two additional challenges in order to maximize the benefit of AAC Technologies. I have alluded to the need to educate end users in UCD so that they are equipped to call for innovation in the way we design digital AAC. Finally, by working with AAC industry, we can support the transfer of innovative ideas to support easier, more intuitive support for communication. It has been a privilege to share some of my passion for AAC and participation with you today, and I look forward to our discussions. Thank you.